Question 19. Two ships are there in the sea on either side of a lighthouse in such a way that the ships and the lighthouse are in the same straight line. The angles of depression of two ships as observed from the top of the lighthouse are 60° and 45°. If the height of the lighthouse is 200 meters, they find the distance between the two ships. Now moving towards the solution, we get this figure. 45° and 60° are the angle of 45° and 60° are the angle of depression, and let we have supposed d be the distance between two ships which we have to find. We have to find this d, and suppose a distance of one ship from the lighthouse is x meter. We have taken distance from one ship, let be x meters, and the distance from the other ship from the lighthouse is d minus x. Because total distance is d, so d minus x will be the distance left amount of distance from the other ship. Then next slide. In the right angle triangle ADO, we took tan 45, and tan 45 is OD upon AD by using 90-degree by using a right angle triangle. Tan 45° is equal to OD upon AD, which is further equal to OD is given 200 height, and AD is, we supposed is x. 200 upon x, and tan 45° value is 1. So by equating we get the value of x equals to 200. In right angle triangle BDO, we took the ratio of 60°, as 60° is the angle of depression, so tan 60° equals to OD upon BD. OD is same the height of 200, and BD the distance d minus x from the other shape, and value of tan 60° is √3. So equating √3 with the 200 upon d minus x, we get the equation x equals to 200. We'll put this 200 value in equation d minus x equals to 200 upon √3. On solving further, we get the value of d is 200 √3 plus 1 upon √3. On putting the value of approximate value of √3 given in the question, we get the approximate value of d as 316 meter, which is the distance between two ships. Thank you.